In 2013, Voyager 1 reached a historic milestone by becoming the first human spacecraft to enter interstellar space, accomplishing this feat 36 years after leaving Earth. The observatory is currently 14.5 billion miles from Earth, so it takes about 20 hours and 33 minutes to send and receive messages. NASA experts did not expect Voyager 1 to continue exploring space for more than 6 months, but the vehicle exceeded expectations after discovering 500 unknown objects in space. Now, world-renowned podcaster Joe Rogan has joined the conversation to share the incredible results of this extraordinary discovery. What are these mysterious objects? Are they related to aliens or a malfunctioning plane? Join us as we explore how Voyager 1 spotted 500 unidentified objects floating in space and discover Joe Rogan's incredible discoveries. Have you ever wondered why, despite the unimaginable vastness of the universe, we are not looking for real evidence of the existence of alien civilizations? This problem is called the Fermi paradox, and it has fascinated scientists for centuries. However, a recent encounter in the depths of space has surprised scientists and may shed light on the age-old question of whether aliens exist. Joe Rogan, an experienced podcaster known for discussing the possibility of aliens and extraterrestrial civilizations, has previously hosted guests such as David Brush and other scientists on the possibility of life beyond Earth. Now, new data from Voyager may first hold the key to answering the question of whether we really are alone in the universe. Watch as Joe Rogan explains why Voyager 1's announcement that it detected 500 objects moving through space is a game-changer, and how it can affect you no matter where you are in the world. But before we get to the fun part, let's understand how the Voyager 1 mission happened. Isn't it surprising to think that our wonderful world with its endless oceans and towering mountains is just a small part of a bigger universe? Scientists have wondered about this for centuries, but it wasn't until the 1970s that NASA scientists were able to understand the scale of our space community. It all started with the unexpected conjunction of the 4 largest planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. In the middle of the celestial dance, medical student Gary Flandreau, who worked part-time at NASA's Jet Propulsion Laboratory while studying at Caltech, made a very surprising discovery. Carefully calculating and planning the orbits of the giant planets, Flandreau discovered a phenomenon in the sky that would revolutionize space exploration. Flandreau's observations were nothing but encouraging. In the late 1970s and early 1980s, these 4 planets were observed in a fascinating arrangement, like pearls in a cosmic necklace that included the Earth. This discovery excited NASA because it offered an unprecedented opportunity to improve space travel. Using the gravitational aids available on each planet, the spacecraft could propel itself using a force similar to the pull of invisible cosmic strings. Flanders' prediction showed that the gravitational contribution of the giant planets could reduce the flight time between Earth and Neptune from a frightening 30 years to just 12 years. However, there was a catch. This remarkable alignment only happens once every 176 years. NASA recognized the importance of this once-in-a-lifetime opportunity and embarked on a planetary exploration mission. 2 spacecraft, Voyager 1 and Voyager 2, were built with the same design and mission and were launched 15 days apart in the summer of 1977. The 2 probes sought to unravel the mysteries of the solar system and beyond. Voyager 1 was launched on September 5, 1977, and became an important part of the Voyager program. It is a sign of humanity's curiosity and quest for knowledge. For nearly 50 years, this incredible spacecraft has continued to travel, bringing valuable information back to Earth through NASA's Deep Space Network. It has become our eyes and ears in the vastness of space, a bridge between our known world and the unknown. As you admire Voyager 1's incredible journey, it's worth noting that it's only a breath away from Earth. In August 2023, the observatory will be a staggering 14.5 billion miles from our planet. Carefully designed and built by the brilliant minds of NASA's Jet Propulsion Laboratory and powered by a Titan III launch vehicle, it began its adventure from Launch Complex 41 at Cape Canaveral Air Force Station. Now, let's dive deeper into this amazing study: 500 unknown objects floating in space, and Joe Rogan's recent The Joe Rogan podcast to an exciting explanation. How did Voyager reach interstellar space? Imagine an astronaut venturing into the great unknown and conquering the vastness of deep space within 10 years. That's Voyager 1 for you. This brave spacecraft is already an incredible 14.5 billion miles from our planet. Consider this for a moment. This distance is equivalent to about 3.6 times the distance between the Earth and the Sun per year. But there is much more to Voyager 1 than speed, distance, and longevity. It also offered a big reveal, including the recent discovery of 500 unknown objects hidden in a huge room. This discovery is unlike anything we have seen or analyzed before. It is a treasure trove of cosmic mysteries and wonders, and we reveal the details of this revelation. You may be wondering how a spacecraft launched in 1977 continues to function and provide such fascinating information. The answer lies in the excellent design and vision used in the design of Voyager 1. One of the main secrets to its longevity is having two spare computers. Voyager and its twin, Voyager 2, are equipped with two computer subsystems, the Flight Data Subsystem, FDS, and the Attitude and Joint Control Subsystem, ACS. This redundancy is a brilliant move that ensures system flexibility and the ability to activate computer components when needed, thus extending their life. The Voyager spacecraft computer system is configured as a distributed system consisting of three doubly redundant computers. This intelligent design ensures that even if one of the systems fails, the others can manage the mission smoothly, avoiding compromising the main objectives. To take advantage of limited power consumption, Voyager devices use hard logic. In other words, computer systems are designed with complex algorithms that operate within energy budgets and time constraints. Power management during spacecraft construction was a critical factor in maintaining operational integrity. Voyager 1's distance from the Sun presents a significant challenge to its ability to harness solar energy efficiently. To maximize energy efficiency, engineers had to find innovative ways to optimize energy use. One such strategy involved prioritizing power in critical processes. Engineers examined components or subsystems that were not critical to the mission. For example, the heaters of some scientific instruments were turned off. These heaters are designed to ensure that the equipment is kept at a certain temperature for efficient operation. When turned off, they reduce power consumption and extend the overall lifespan of the spacecraft. However, power management decisions for critical processes are not made lightly. These include a thorough analysis of the trade-offs between energy conservation and mission objectives. Engineers work closely with scientists to ensure that eliminating certain methods does not compromise the quality and usability of scientific information. The goal is to find a delicate balance that maximizes energy efficiency while maintaining critical performance. Voyager 1's power management system adapts to changing environments. As the spacecraft moves away from the Sun, solar energy decreases, but Voyager 1 adjusts its energy consumption accordingly, ensuring sufficient resources to support critical operations and data transmission. It is like
smart energy-saving device. Over the years, there have been major technical advances and improvements in power management. Engineers continue to improve Voyager's energy efficiency with improvements such as increased power transmission, improved battery charging systems, and improved electrical and thermal management. Thanks to these effective energy management strategies, Voyager 1 exceeded all expectations. Nearly 6 months after publication, it continues to provide critical insights. Considering that this spacewalk was first performed only 5 years ago, the longevity of Voyager 1 is truly surprising. It speaks to the dedication and creativity of the scientists and engineers working tirelessly to pilot Voyager 1. But let's not forget that the depths of space are full of surprises, so stay tuned for new discoveries. Designed to explore the solar system and beyond, the Voyager mission is equipped with an impressive array of electronic instruments and systems. These instruments were contained in the spacecraft body, which consisted of 65,000 individual parts. Although Voyager began its interstellar journey with several working instruments, Voyager 1 still has only 4 and Voyager 2 5. One of the long-term instruments on Voyager 1 and Voyager 2 is the Low-Energy Charged Particle Instrument. This device has 3 sets of particle sensors that measure the number and speed of low-energy particles that hit it, tirelessly track cosmic rays and take detailed pictures of the sun, planets, and interstellar space. An additional instrument, the Cosmic Ray Instrument, actively searches for high-energy particles from the sun and other galactic sources. These cosmic radio instruments are now detecting materials from the vast interstellar space and the protective bubble formed by the sun. These values proved crucial in determining when Voyager 1 entered interstellar space. It is worth noting that the device is still working on both Voyager 1 and Voyager 2.2 long antennas at right angles to each other. The plasma wave subsystem is an important tool for measuring the electromagnetic field of potentially undiscovered exoplanets. But its role evolved when Voyager entered interstellar space. Today, the device provides information about how plasma waves change as they travel through space. In addition, magnetometer observations, originally designed to study the magnetic fields of the outer planets, now play an important role in the study of Earth's outer core and Earth's central core transition zone. Scientists use this instrument to study the magnetic properties of the changing region.